Thank you, Marcel. I'm happy to get up here to speak on a somewhat controversial topic, how to not contribute to NF Core, specifically best practices for using NF Core tooling outside of the open source NF Core organization. A little bit about myself so you can know what my background and interest in this matter is. I did my PhD at Yale developing non-Nextflow pipelines to discover structured non-coding RNA families. I then moved into industry where I discovered Nextflow as a computational biologist at a brand new biotech startup. I helped build a platform with them for novel protein discovery. I then moved into a role as a software engineer with a clinical genomics company, helping them with a migration of Whittle on-prem pipelines to modern Nextflow and Seqera platform in the cloud. The thread that has kind of led me throughout my career so far is the same one that got presented by Evan at the Nextflow Summit in Boston, that better science can come through better software. And that's part of what led me to join Seqera on the community team about 2 months ago. Now, turning to the topic of my talk, many commercial biopharma companies are building on NF Core tooling. And I saw that personally in my roles at my previous companies that I worked for. And it also just makes a lot of sense. NF Core is an incredible resource in terms of pipelines, modules, sub-workflows, test data, and container images that are ready to begin using and can greatly accelerate the science that a company is trying to achieve. Now, as more and more companies are beginning to build using NF Core tooling, there is, I think, some need to talk a little bit about, at a high level, of what are some of the practices and different ways you can go about building on NF Core tooling to achieve what you need to in terms of accelerating your science while keeping some things that are needed to be private, while also sharing openly when that is possible. So I'm going to talk about a couple of different options that are ways to do this, from putting setting configuration for existing pipelines and files, setting up version-controlled institutional configurations, best practices for setting up private forks of NF Core pipelines, writing custom Nextflow plugins that allow you to extend the capabilities of Nextflow, how to build custom pipelines from scratch, also using NF Core tooling, and finally, how to set up a modules library. I won't be able to provide detailed how-to guides on all of these, but I am going to attempt to link to community resources where you can find examples of these types of approaches in action. First off, something that is surprising to many people who haven't much experience with NF Core pipelines is just how incredibly configurable they are. A lot of times people assume they will need to write a new pipeline or fork a pipeline, when actually everything that they want to customize can be done just by adding a couple of lines of configuration. For example, if you need to add the command line argument -- no group to how fast QC is being run, you can apply a simple 3-line block of configuration that will do that change to how the pipeline runs. Now, if you want to deploy this at scale, it's very easy to do this with Seqera platform. You can drop that block of text into the Seqera platform launchpad and then make that available to all of the scientists in your institution. Another way to do this, if you want to version control this configuration, is perhaps to set up an institutional configuration. This can be done using the same patterns as NF Core configs, where lots of educational, institutional, and biopharma companies have set up either configurations for how to run their pipelines or links to the private sources where they want to store this configuration. And this is very well integrated into NF Core and makes it very easy for scientists who want to run NF Core pipelines to access the customized configurations of those pipelines that you want to make available within your organization. Now, when it comes to private forks, my recommendation is, when possible, try to avoid this. And largely this comes down to the internal workings of an NF Core pipeline are not stable. We keep the parameter names stable between releases. So the user-facing components are going to be able to be used, but sometimes there's major refactorings that happen. And if you create a private fork that you add code onto, you run the risk of being stuck on an older version of a pipeline and not being able to benefit from all of the advancements happening in the NF Core community. But sometimes there's no other way. So if you do need to do it, make sure that all of the changes that you can change via configs are done so. Pick an organizational namespace that you're going to use for files that you add to your forked repository, and try to include the new code as sub-workflows and modules, and continue using NF Core modules and best practices throughout. Now, one of the more common reasons people think they need to fork a pipeline and start adding custom modules is they need to access an institutional data lake to either grab data or put data back. That's actually not necessary for setting up a pipeline. Another really good way to do this is by using a Nextflow plugin, which can be configured to grab the data from a particular location and a particular way. And if you want to see a way to do this, take a look at these plugins by our Summit sponsor Quilt. The archived version of this plugin at nextflow-io has a good example of doing this with primarily Python-based tooling and using Java and Groovy as a wrapper around that. And then the Quilt data /NF Quilt one has an example of a full-fledged, fully Groovy and Java implementation of this type of plugin. Now, if you're looking to build new pipelines using NF Core tools, Julia just gave an incredible demonstration of the new features that are available through the NF Core tools CLI and text user interface. And the fact that there are over 20 different parts of the template that can be customized is a great enabler for organizations that are looking to take advantage of best practices from NF Core pipelines, while only putting the pieces that they need into their pipeline templates. So I highly recommend any organization doing development work of Nextflow consider using these best practice templates, because they have been battle tested across executions that are run all across the globe at production scale. Now, one other way to begin taking advantage of NF Core tooling is maintaining your own modules library. And I just want to talk a little bit about how incredible the NF Core modules library is. NF Core has built the tooling to make code fair in a way that I don't think any other organization has done. And each of these findable, accessible, interoperable, and reusable principles of fair data have CLI commands that work for NF Core tools. And if you set up your own modules library, you can simply add --git remote and where you have your modules library to begin using this same kind of tooling for your personal code bases that you need in your organization. Now, one specific repository that I want to call out as an example of this in action is the Memorial Sloan Kettering Cancer Center's Omics Workflows modules repository. You can take a look here and see how they've begun to modularize some of their code that doesn't fit as well in the NF Core modules repo, but they want to have available for their own use. I also, on my personal GitHub, have a copier template where you can use 2 CLI commands, pipx install copier, and then copier my repo and your folder to be able to generate a custom modules repo that you can deploy to your organization. This is still a work in progress, but the basic functionality is there, and more contributions are certainly welcome. So looking at this wealth of different options for building with NF Core tooling, you might start to wonder, why are biopharma organizations choosing to contribute to NF Core regardless? And I think what this comes down to is that open software often enables better science. And that comes down to a couple of different reasons. First, With open software, there is a shared maintenance burden of these communal resources. Organizations can work together to maintain these important pipelines, find bugs, add new features, and that really enables everyone to work together towards those common goals. Second, continuous peer review of code enables better accuracy. And meta reviews of bioinformatics softwares has shown that the best predictor by far of bioinformatics software accuracy is the number of commits in a GitHub repo, the number of issues that have been filed in the repo, the number of commits, the number of issues, and there's one more GitHub stat that I'm blanking on. Finally, the last reason why I think commercial biopharma companies are beginning to contribute more and more to NF Core is that they've discovered that they can lower their compliance burden for regulatory matters by relying on an external vendor like NF Core that has the appropriate processes, tooling, and patterns in place to generate well-tested, reproducible software. Now, if you are at a developer or a leader at an organization that you want to help move more into this direction, how can you do that? So, one way as an individual contributor is to be an open advocate. And a good way to begin is to organize trainings on best practices tooling within your organization. And the community team, we've developed repositories called training.nextflow.io, which work for anyone to begin delivering trainings that they need, and so people can start learning how to use this tooling. You can also practice inner source, where you use open source tooling and practices in how you develop your internal code within your organization. Begin showing that culture within people that you collaborate with. Finally, as you communicate about open source within your organization, emphasize the business value and how this is helping your company reach its goals. And the NF Core is a great community to continue working on that. Next, if you are a leader trying to shift the organization more towards open building, develop and publish an open source strategy document that outlines what are the benefits and how developers who are working on with open tooling can interact with those resources. Consider seriously contributing funding and resources to maintaining these key open source projects that you rely on. And think carefully and distinguish between proprietary data and proprietary analysis, because a lot of times the data is far more sensitive than how you are doing the analysis. One organization that I want to call out specifically is the To-Do group, which is Talk Openly, Develop Openly. And this is a group of open source practitioners and program officers among tech firms that are collaborating and open sourcing a lot of their open source documentation and policies. You can find great examples there on how to do that. Finally, it's my hope that by working together, and that organizations across from academia to industry can achieve this goal of having better open science through better open software. Thank you.